Hi, I'm Luke from BagMe, and in this episode of Making Materials, we're heading 1 hour north of Chi Ming City to one of our most important suppliers, ENS. In this video, we're going to be talking about a material that's not often seen in backpacks, but it's almost always there. So hang on for the ride. It gets crazy around here. Look at this, it's always cool to come into the ENS Sample Room and see all of the cool things that are being developed at the moment or that are even on the market already. So you probably think that foam is a boring subject, but after seeing this video, I think you're going to have a completely different idea. So ENS are working with some of the most reputable brands in the world and with some fantastic designers, and together they're all coming up with different ways to put foams together to create really innovative products. So we're not going to talk about the science of foams in this video. Today it's going to be more about the practical application of foams in relation to bags, backpacks and luggage. There's 4 different foam types you're going to hear a lot about. The first one is polyethylene foam, and this is actually made here. Another foam that you're going to see is Ethylene, also a polyethylene foam, but it's a cross-linked foam and it has a lot more structure. Now you see here we have a different foam stuck on top of this one. This is an EVA foam, also made in-house. EVA is used for all sorts of things in bags and backpacks, ranging from these photo inserts here, which we'll show you outside, these luggage parts on the wall over here, and there are many other ways EVA can be used as well. We're going to show you the cutting tools because all of these parts have to be cut out, of course. We're going to show you how the cutting tools are made. And the other foam that we're going to show you is polyurethane foam. And James here is going to take us on a tour around the factory and show us how everything's done. So what are we going to start with first?
We will get started of the PE foam production.
Okay, you get started. So the machine's not working now?
No, it's not working now.
So can we go and have a look during lunchtime so we can have a look inside the machine?
Oh, sure. Yeah, let's go.
So this machine here is producing the
Polyethylene, yes, correct.
Yeah. Okay, and what I have here is this tube where all of this raw material is going to come through. And this tube here gets fitted into the machine right here. And what have you got, James?
This tool here is installed outside, so it comes as a one set. What I'm doing now is to adjust the thickness. If the width is getting wider, then the thickness of the PE foam is getting thicker. And if it gets narrower, then the thickness is getting thinner.
So basically the raw material gets shot out of here in this direction, right?
Yes, correct.
And this machine produces hot air, which blows into the middle of the
PE, yes.
Blows it up.
Yes. Then it goes to here, through to the ring here. And then there is a blade here, it cut half. And then there is another blowing air here to make the PE foam cool down.
Okay, so there's all these holes here where there's going to be air pressure blowing out here. You're going to see it, it's really awesome. And then I guess we can look at the rest after lunch. Let's do that, hey?
Okay. We just started the production of the PE foam.
Okay.
There is 2 big drums here, as you can see. One drum is that we keep the virgin raw materials, and the other one that we keep for the recycled raw materials.
So that gets sucked up through these tubes and into the top here, right?
Yeah, the ratio of recycling raw material is about 30%.
30% recycled?
Yes, correct.
Okay.
We cannot add more than 30% if then the PE foam gets ripped easily and also the surface is getting more rough. So I will show you with the machine over here. This is the place where we keep the pigment, the dyeing materials.
Okay.
Yeah, and then these big drums have raw materials. That's the raw material that we call as a LDPE. That's the main material of the PE foams.
It's a low density polyethylene, right?
Exactly, yes, correct. It mixes up together and then it goes through to the chamber.
So James, what's this first chamber here for? It's quite hot.
Okay, so there are 2 chambers as you can see. So the first chamber is mixing and melting of the raw material.
All right, now I see this pipe coming in here.
Yeah, from the outside, yes. That is the channel where the gas comes from. So in melting, mixing with the gas, prepare for the blowing.
Blowing is like creating the bubbles in the...
Create the bubbles and then prepare for the foaming.
Okay.
So water like cooling the machine.
Alrighty. But still a lot of heat coming out of there. Yeah. And then I see they're at the end of the machine here starting to pull the raw material out, right?
Yes, correct. Yeah. So the one that you are seeing now is kind of warming up the machine.
Okay.
Yeah.
So this material that's being wasted as the machine's warming up is what those pallets are made of.
Yes, correct.
Okay.
Yeah.
Alrighty. And how long will this take?
We don't say time, but we say like the amount of the wastage of the PE foam. It's about like 300 meters to 500 meters.
Oh, really?
So it's not small.
So that's another good reason to think about MOQs, because every time this machine gets started, there's 200 meters of this material that's going to have to get reprocessed back into the system. This thing can produce how much per day?
We can produce about 30,000 meters per day.
30,000 meters per day. So James, I see here we have 3mm PE, right?
Correct.
And these rolls are quite big.
Yeah. The amount of the PE foam that we wore is different, depends on the thickness. If the thickness is getting thicker, then the amount is getting less.
And then this roll gets stored for a week, right? You told me?
Because the PE foam already contains the gas. So that's why we store in the warehouse for about 7 days to make sure that all the gases is going away. We need to make shrinkage enough before it goes to the production side.
Okay.
Yeah.
All right, but I order 10mm sometimes. How do we do that?
So in that case, we laminate 2 layers of the PE foam by heat.
Can we go and have a look at that process?
Sure, yeah, let's go. So this is the process that we laminate 2 layers of different thickness of the PE foam by heat. So if you see more closely inside here, then you can put your hand here, then you can feel the warm air, right? It's
Okay.
really hot.
So there's no glue, it's just purely, purely
glue.
heat.
So there are 2 types of the foam material that we can laminate by heat, which are PE and then the ethylene foam.
Alrighty, and it's obviously making it flatter a bit too, so these waves are a little bit less.
Yes.
So we order 10mm PE for low-cost bags, you know, in shoulder straps and back panels, but I've never had any problem with the delaminating, so it's a pretty strong bond, right?
Yes, correct. So it works like this. So there is a cell here and the other cell here from the another, 2 different layers. Once it gets heat, the cell is getting open.
Okay.
And then once it gets cooled down, it close together.
Okay, got
And
it.
it link together.
Okay, cool. Nice one. So obviously when you send this to us at the factory, we're not seeing rolls this big, right?
Right. And then we roll like between like 50 meters to 100 meters and we supply to the back factory.
Yeah.
And then this is a place where we store after the heating lamination for a while. So once the PE foam is produced, then we move the PE foams to store like 7 days. After the 7 days, once it gets shrink enough, then it's sending it to the bulk production at the die cut facility, or we roll up and then we deliver it to the back factories. Here, when you compare with the original PE rolls without the heating lamination, not yet. Yeah, then
waves.
the waves is getting more flat.
Yeah. Okay, and these waves that you see in the material is obviously created from that point where the raw material is extruded out of that machine. James, can we do more than 2 layers?
Oh yeah, so in case if we need to make 3 centimeters, we need to make the layers like 6 layers using 5 millimeters.
All right, and what's the limit?
So I think we haven't tried for the maximum layers yet, so but what we have tried is about like 20 layers until now.
Oh, really?
Yeah, so which means it's about like 10 centimeters.
Okay. Obviously not for a backpack.
Yeah, correct.
Cool. So we're going to go over to the recycling where they reprocess the polyethylene foam.
You can see the wastage from the die cut facility.
Oh, okay, this will all get reprocessed.
Yes.
Well, it's not laminated, right? This one is heat,
Heats, yes, correct.
so there's no glues in there to affect the recycled material.
That's why we can do the recycling.
This material here is from the extrusion machine, right?
Yes, this is the waste heat that comes from the warming up the PE foam production. This is the first stage of the recycling process of the PE foam. This machine is cut into the small pieces for easier melting. And then it goes to the chamber here, it melting in the chamber. And then it comes through to the mold, like the small holes, like the piping. Material, this one is exactly same as the PE piping. At the end, we cut into small pieces as like the pallet that you just saw in the drum.
Alrighty. Okay, so this is the very hot PE pellets that are recycled from the waste that's created from starting up the PE extrusion machine. This is a room where all of the die-cut molds are made.
Actually, we have two laser cutting machines here. We put the patterns into the computer over there.
Which basically the factory, or we send you the pattern file, right?
Yeah.
And then the laser cutting machine here is outlining the pattern pieces and cutting a groove so the knife can be inserted into these grooves. And you can see here, there's actually a groove cut out here by the laser where the knife will go into.
So the next step, after we make the laser die cut mold, then we bending the knife. That is the automatic knife bending machine over there. So we just insert the patterns of the knife into the machine, and then the bending machine is bending the knife according to the pattern file.
That's really cool, right? And then from there we have a piece like this, very sharp. And this guy here is actually going to insert that piece into the wood right here. So what I find really cool about this too is how accurate obviously the laser cutter is accurate, but how the second machine that's actually bending this steel is also accurate to the laser cutter. So they always fit perfectly. That's it, super cool, right? Obviously this mold is going to have 6 pieces there, and it's quite a complex piece, so you actually have a bit of wastage of material in between. So if that's, single layer EVA, a lot of that waste can be reprocessed into recycled EVA later on. One really interesting thing I'm really looking forward to showing you is that where these things are stored. This long storage area here, to me, is like the Library of Alexandria of cutting tools. And believe it or not, in this building here, there are over 80,000 die-cut molds from about 60 factories around Saigon. Now, if you own a backpack, chances are the foam in your backpack was cut from a cutting tool in this storage area here, and it goes all the way around the corner. Cool. What do we got here? So here we have a cutting tool from Vision. So James, how do you keep track of all of these cutting tools in here?
So there is one person who is managing and find out all the die-cut molds.
One person manages this whole thing?
Yes, but she's only taking care of the die-cut molds.
Oh, really?
Yeah.
Wow, unbelievable. It really looks like an archive to me,
Oh yeah. We organize every 2-3 years.
And I also see it continues in this room and around the corner, right?
Yes, correct.
Unbelievable. So let's go and see how this stuff is all cut. So here we are in the cutting area. So James.
Yeah, I just bring another patterns which go insert to the viral backpacks.
Okay, and this pattern piece you see is a pretty simple square piece, so we don't get much loss in between. And this is for a panel around the base of the backpack actually. And this is the back.
Then this is the front size. The knives are in between the foam here.
Alrighty.
Yeah.
Here's an example of where we have 2 different foams laminated together. Now later we'll show you the machine that this is done on. Here we have an EVA material. We have 5mm of EVA. And the EVA is more dense because it creates the structure that we want. But this is harder than what we want sitting on a shoulder. So that's why we have the polyurethane foam on this side, which is a nice soft open cell foam. And that creates the comfort we need against the skin. So it's a pretty simple process, and you can check it out what's going on over here. So on the board here, we have a cutting tool, and in here are the blades, and we have a nice soft PE foam here, protecting the blades, and as the weight is pushed down and the foam is cut, that foam will also push the foam pieces up out of the knife. And then voila, here you go, we have Firo shoulder straps. So here we are where the EVA is produced, and James here is going to show us through the entire process from raw material, right, all the way to how these big sheets of EVA are formed. So James, this is a raw material here, right?
Yeah, it is the pallet is mixing with the three main raw material there is, which is Ethylene-Vinyl Acetate.
Yeah.
This is the LDPE also. This is the one of the raw material that we mixed with the EVA foam. But there are other several types of the raw material that we're mixing with. So we put the EVA pallets, the raw material first into the machine, and then all the mixing is finished, and then we put another agent together into the machine.
That last bag you saw going in with the yellow material is the gluing agent that gets all of the other compounds stuck together when it's being mixed up. So this machine is mixing up all of these into one big cookie dough.
Yeah, exactly.
And this mixture is about to come out the back of this machine. Okay, let's run around and have a look at that.
So it's coming now. The dough is coming now to the tray.
Okay, so this material is going to be dumped into these rollers.
Yes, to make it flat, like a thin, flat sheet, to prepare to putting into the forming machine.
So I see that they're putting the sheets through again and again. What's happening here?
The dough comes as like the round and the big kind of like rocks, right? And then we make as a sheet, flat sheet, so that all the raw material goes evenly.
So I see over here, just coming through the machine to create nice, flat, even sheets.
That machine cut the width, right? And then we need another knife to cut the length here.
And this guy here, he's counting how many sheets that he's stacking up. So question, James, like, why don't they just make one thick sheet before it's put in the oven? Why does it have to be in sheets of 10?
If we make it as a like thick foam sheet, then when it gets formed at the machine, it does not get heat evenly.
Okay, so from here, this gets taken over to the big oven, right?
Yes, correct.
Alrighty, let's go and have a look at the big oven. Okay, so this guy is now cleaning out the oven, ready for the next lot to go in.
Can you see the inside of the mold? Inside here? This sizing of the mold also like makes the foam density higher or lower. So we put like about this size sheet, about 10 layers, we put this one into each space, into the machine. So we set up the time as 46 minutes.
After all of the small sheets of this EVA are loaded into the machine is going to get closed and the material is going to be cooked for about 43 minutes under high heat. Now it's important to note that during that time, the material is not allowed to expand, and that's controlled by the size of the cavity in the mold.
1 minute. Please come back. You will hear the alarm right before the foam's coming out.
Now what's really cool about this process is the expansion of the foam happens in an instant. So the machine is holding those sheets under pressure, and as the machine opens up, the EVA bursts out of the machine and becomes about 25 times the original size of the sheets that were put in there. You can feel the heat coming off it.
It's pretty hot actually.
And so what are they doing now, James?
They are kind of trimming now.
And why do they do that now and not once it's cooled down?
We can cut it more easily when it's hot and soft.
So James, what were you saying about the density of this EVA?
This is the EVA 23 degree.
So 23 is a number that
we measure by device of Choi. Okay, so it's a small device they use both, right? Yeah.
Okay, so the lower the number of the EVA foam, like 15 or 23, is a softer material.
Yes,
and
correct.
The hardest material we can go to is about 70, right?
Up to 70 or a little bit more higher.
Yeah.
Okay, but So as I told you before, if the foam is forming less, which means like smaller size, the foam is getting harder, stiffer.
Okay.
So which means the sizing of the EVA 70 degree will be smaller than 23.
Oh, really? The sheets come out of the oven smaller?
Yes.
And do they use the same cavity space in the
No, actually we change the mold sizing as well, mold.
Okay, so it actually, but the same amount of sheets and the same sheet size goes into that space?
Yes. But the recipe is different.
So with EVA, we can use a softer EVA like this for a shoulder strap. And if we want more structure or stability in a product like a back panel, we can use a harder EVA, maybe even go 3 millimeters thick to create the structure, and then put softer foams with it to create some comfort. So James, before we go over and see how this material is sliced, I want to know a little bit more about the color EVA. But over here, I see there's a lot of color samples in this cupboard over here. Can you tell us more about that?
Okay. So there are 4 types of the main material at the bag industry, right? Which is the PE, PU, Ethylene, EVA foam. But the reason that we are making the custom colors with EVA foam only is because that it has less MOQ than other types of the PU foam first.
But also when it comes to making backpacks, you'll see a lot of backpacks where you see a net mesh over an EVA foam on the back panel, right? And we're not really using PU foams under there anyway, so EVA is the right material to use.
Yes, correct. Second, the EVA foam express colors much better than other types of the foam materials. Okay, but still, the EVA foam is the type of the foam material, so it is really difficult to express the colors with the EVA foam. But in order to make one custom colors, we need to lap dip at least like 20 times, 30 times to make one accurate custom colors. That's why it takes about 2 weeks. But still, even we try 20 times, 30 times, the color still not matching 100%. So it is really difficult to make 100% exact custom colors based on the Pantone numbers or color numbers.
Yeah. So 2 weeks of work, 30 tries to get one color I asked for.
Yes, correct. Or even more sometimes.
Yeah. See, sometimes even I have to think about how this affects MOQs. You know, that's a lot of work.
Yeah. So that's why if you see inside over here, then you can see here how many sheets that we have here to make one colors.
So where are we going next, James?
So we are going to the skiving area where we're slicing the EVA foams.
Okay, James, I see there's a lot of these big EVA sheets sitting in here.
Yes.
I believe this is for what we call shrinkage.
Yeah, shrinkage period, or we can say cooling or aging.
Aging.
Yes.
Okay.
Right after the production of the EVA foam, the EVA foam is very hot, and then during it get cool, the size is getting smaller, and then the thickness is getting thinner, and then the stiffness also getting stiffer too.
Oh, really?
Because this area is very windy, so that's why we store it in the outside.
Okay. Now we're going to see, you call it skiving.
Externally, we call it a slicing. Once the EVA foam is produced, and after it gets cooled for 2 weeks, and we slicing the skin, and then we slicing the thickness that we need. And if you see closely here, the blade is rotating and then slicing the EVA foam sheets, not just cutting.
So, James, this foam here looks like 12 or 15 millimeters?
Yes, correct. This is the 12 millimeters that we sliced.
And the tolerance?
The tolerance is about plus minus 0.3 millimeters.
Generally speaking, for backpacks, we're using foam that's sliced anywhere between 3 millimeters all the way up to about usually 10 millimeters for us. The use cases for the thinner foams would usually be like for example, we could have a foam like this, 8 millimeters thick, a nice soft one in the shoulder strap, and have a single density foam. But I can have a shoulder strap where I have a harder density foam, maybe 3, 4, 5 millimeters thick, and then bond a softer PU foam at the bottom so you get the nice comfort feel against your shoulders. There's many reasons why we laminate and bond different foams together, and next we're going to go over there and show you how it's done. So I see here we've got a lycra material. Yes. So we have the fabric that's outsourced, and it's going to be laminated to the foam. The
foam is going underneath, and then the fabric going from the upper side, and then it meets in the middle. As you can see here, there is a tray where all the glue is keeping. So there are two types of the glue, which is oil-based glue and then the water-based glue. But to the foam material, only the oil-based glue is workable. All our glues have the MSDS. You know, most of the big brands are requesting for the MSDS.
And these big brands, I'm guessing, is high volume brands like from Europe who also need to meet REACH standards, or California Prop 65.
Correct. But the glue in the tray, it does not apply to the foam material directly. The glue actually applies to the roller, and then the glue on the roller applies to the foam material. Then after it applies to the foam material, it goes together with the fabric, and then how we laminate together inside. So there are two rollers here. They are keeping in the both sides to make sure that it pressed well, and then it roll up. And then after that, it goes to the cooling area, and then we keep it here at least 1 or 2 days.
We use a similar surface material like this on Firo. You probably know Firo, shout out to Aaron. And the back panels, we actually use a similar lycra like this, but we laminate a polyurethane, like a soft open cell foam underneath it. And that's what's actually forming the back panel of that bag and the material that you feel underneath the shoulder straps. So there's many things that can be done with this laminated material, and it's really important for us as developers that we do get a nice smooth finish on a material like this, and we don't have bubbles and things in between from the glue. So good stuff.
So this place is the place where we do the molding.
We're doing the lid for Firo here. Yeah.
Once we cut as a rectangular shape of the EVA foam, we put it into the oven to get heats for easier shaping. And then it goes into the molding machines. Normally, we set up the time as a 100 second. So let's see.
So with this Firo piece, you can see there's two pieces in one sheet of foam. When we cut this out, we actually insert this into fabric. Yeah, so this is clean EVA. But what can actually be done is we can laminate any kind of, well, most kind of fabrics on top of the EVA and press it into whatever shape. And that's where you get these big, like, hard luggage cases as well, where you see like a nylon fabric on the outside. So here we go, oven's open. Okay, James, do you want to explain the mold that we see here?
So as you can see, there is a positive and then the negative. So the positive mold, compressing it to the negative mold, and then how the shape is made.
Okay. Now, when we're making samples, we actually make these molds out of wood, so they only last a few compressions, but it makes it a lot cheaper to make samples with. You know, these aluminium molds, CNC cut, they cost a little bit more, but they last a lot longer for bulk production.
One more information that I want to let you know is if we're using nylon fabric for the molding, then it's starting to get shrink and wrinkles. That's why we suggest to use polyester fabric. That's because the polyester dyeing temperature is about 160 degrees. But there are some fabric supplier who developed the nylon fabric workable for the molding.
Oh, really?
Yeah, but there still have some limitation on the shape and then the sizing.
Good to know.
Yeah.
You always learn new things when you're working directly with the suppliers. So let's go over to the cutting table. So actually, this part is quite labor intensive. Because of the three-dimensional shape of a lot of these molds, the parts have to be cut out by hand, and that's all happening around this table here.
Once the foam gets heat, the size is getting smaller when it cools down, right? There are some molds that we can use the die cut, but normally we cut by hand. That's because that after it gets heat, the shrinkage of each pieces are different.
This might end up 2 millimeters shorter than something that was produced a couple of days before, because the shrinkage will be different.
And for the luggage product size, the plus minus about 5 millimeters. So if the size is getting bigger, the tolerance amount is also getting bigger too.
One thing I notice about these hand-cut pieces, look at the consistency there. She's doing a really nice job. That's remarkable. There's another thing that I want to show you here, which is quite interesting. You see pieces like this that are cut out. Yeah, we have an edge on the EVA, which is not very nice, okay? What's going to happen with a piece like this is that we'll have fabric folded over here and probably top stitched around this piece. I don't know who this piece is for, but there's actually a new machine that they have here. So you can actually have a really nice edge without having to do any extra work to it, like put a binding on it. So this is a piece that's just come out of the molding machine. And actually I can pop this out Look at this, there's a really beautiful edge on this. There's also some other special foam cutting techniques and processes that are done here at ENS, so can we go over there next?
Okay.
Actually, while we're walking past, here's an example of a luggage base that's just been pressed. So this is EVA, main fabric on top, and this also has to be trimmed the same way as we've just seen back there. Okay, and this is the new machine.
Yes. So this machine is different from the other old molding machine because the material type of the mold tool is made of the steel. Okay, this is the positive mold, this is a knife, and this is a negative mold. The knife on the positive mold makes the mold cut.
For example, this piece has a material on both sides of the EVA.
Yes.
It gets put in there, it gets pressed, but this knife here actually compresses and cuts the edge all in one press, right?
Yes. Right.
And that way we get a much cleaner edge on these parts, and then we don't need to finish these edges or put binding over them or anything, so we can use them raw. So James, what's this machine called?
Okay, this is the machine that we call as a profile foam machines. So there are the foams that we can make with something like the special shape of the foams with the available molds, such as like the triangle shape foams, and then also other types like rectangle shape foams.
So here's a piece of foam, laminated, 3 layers, okay? And you can see this tool here is gonna squash the foam like hell. And before the foam comes back to its original size on the other side, there's a cutting tool that's gonna slice that foam. And then you can open the foam on the other side and you get these patterns in the foam. Oh, look at this one. This is fantastic. Look at this, this is beautiful. You can see that it obviously started its life as 3 layers, 1 black layer in between. And then as it's being pushed through the tool and it's opening up, the knife is actually cutting this pattern through there. Actually, the knife is flat. That's the crazy thing about that.
But there is one limitation. There is a fixed size of the mold. The maximum width that we can make is about 50, and then the length is about 1 meter.
So for example, we could cut parts of a back panel out of this foam, and then we could put like a 2-dimensional mesh over the top of it, you know, to create a breathable back panel on a backpack.
And also there is one more option that we can make a perforated holes even to the profile foams, so that we can make the foam breathable through to the mesh.
Okay, great. James,
Yeah.
it's been a big day here. Is there anything else that you'd like to show us before we go?
There is one more place to go.
Let's go and have a look. All right, just before we go on to the next place, I want to show you the skiving of the foam, because when the foam has got a hard edge on it, sometimes it's not so nice when we sew around the edge and it's a big drop off to the next piece of fabric. So we want to shave the edge, and this is what this machine here does. And once a piece of foam has been skived around the edges, this is what you see. All right, let's catch up with James.
This is the, one of the automatic spray gluing machine.
Okay, that's really cool. This is an Ethylene foam. It has been cut in the machine that we just saw, so you can see the grooves here. Then it has been die cut to cut out the shape and the holes in here. So this is forming a back panel of a bag. Now what's happening here is this gluing machine is precisely placing a glue around here. And then they're taking it over to this table, and there's a woven label going in the back. The logo is presented right in the middle here. So it's a really nice design, whoever designed this. So beautifully done. Another example, this is an Osprey Escape back panel. Shout out to Osprey, really nice job here. I love your work, I really do. So here we have the Ethylene foam, the screen printing, the name of the back panel system, and then the EVA panels are put on there by hand on each side.
But they use the jig to check if the EVA foam attaching to the okay position. See, if they're using the jig, because there is no marking on the attached place of the EVA foams.
But it's placed in there perfectly, yeah. And these things have been made for the last few years, right? So team's got plenty of experience in getting these right.
So it goes to here, and then it goes through to the roller to pressing one more time. So that make sure that the glue is attaching into the whole surface evenly.
So James, I really appreciate you showing us around the factory. Like, I've had a lot of fun with this one.
My pleasure.
And I'm sure a lot of people out there in the industry who are going to watch this, including young designers, product managers. Shout out to all of you. If you like this video, we're going to make a lot more content like this at suppliers like ENS, you know, really the global leaders in their areas. So please like the video, subscribe so you get a notification when the next video comes out, which is going to be soon. James, I really appreciate it. Thank you, ENS. Thank you, James. Thank you, Mr. Lee.